just lines that tell me what direction my drill bit should be leaning when I lean to a specific angle to get the angle that I want for each part. You may remember from the first project that we did use sight lines, but they were pretty much simplified because no leg had both rake and splay. The front leg only had rake and the rear legs only had splay. That meant that our sight lines were basically parallel to the side of our seat and the front of our seat. Well, we're going to be using legs now that have both rake and splay, which means that the sight lines we're going to use are going to diverge from those points of view. And it's important to understand why we use them, how we use them, and then how we derive them from our design. So now I'm going to show you how to translate rake and splay into the sight line so you can use it for your drilling. If you look closely at this image here, what you're going to see is I dropped a little plumb from the center point of where that leg is in the seat. So you can imagine that's a leg effectively with no splay or no rake. Okay? And when you look over at this image, you can imagine as it might march outward and get some splay to it, it's going to fall somewhere along this scale. So it can be 1 degree, it could be 8 degrees, but somewhere in there it's going to happen. So I've decided from, let's say, a drawing I made that I wanted this to be at 5 degrees. And so that's what you're seeing there. So you see the scale here, you see where it falls. Now, the important thing I want to draw your attention to is I've got a term here that you may not have heard before, which is the travel. So usually you think about an angle up here like you might measure it with a protractor, but I want you to start thinking about it as the travel along the floor plane. So this actually travels this far to become 5 degrees down there. The same thing applies when we're looking at the rake. So for instance, if you've got the plumb here and there's 0 travel, and you come over to here and you want a 4-degree angle there that you've decided you like from your drawing, well, here's the scale and it's going to travel that far out when it is at 4 degrees. So it's that distance from plumb that I want to draw your attention to. Because what we're going to do is we're going to use that travel to both lay out and then discern what angle to drill for our sight line. And here's what that looks like. So basically, here's the point at which I dropped my plumb before. So this is the center point. That's where my leg is going to be drilled. And you can see that I've laid out here the travel, or the distance from that other drawing, how far out to the right this leg is going to splay. And I've also measured how far forward this leg is going to be when it's in its rake. So it'll be in this position or this position when it's in one of those alone. But the big question is, what happens when you have it in both of them together? So when it's both in the position of the splay and the rake. Well, if it's this far over and this far forward, what you'll see is the leg actually ends up in this other position completely. And that position is going to give us all the information we need to know. When you take the point at which it ends and draw it back to the point at which all these legs begin, the center point where you're actually going to drill, that actually gives you your sight line. There it is. It's right there established, so that's no problem. The only question left is, how do we know what angle to drill it at? Now, previously we were at 5 degrees here and 4 degrees there, but when you combine the two, you get a third number. You get a number that you're going to have to drill so that when you drill it at this sight line, it's going to end up from the side or the front being those other two numbers. Well, it actually turns out to be pretty easy to find out what angle to drill. Basically, we need to go back to our full scale we had here before. You remember we just decided where this was going to end up, but we can imagine there's a full scale there. So what we do is we basically take the full scale and use it to measure the length of that line. So just like we laid out the travel here, well, we can use the same scale to measure the travel there. So hopefully all that helped you wrap your brain around the concepts between how the sight line and the resultant angle all relate back to the rake and the splay. But there's actually a really easy way that I've got for laying this out. So when I'm working in the most practical manner, just trying to do my job here, I've got this rule here that I've made. This is what I call a sight line rule, or you could think of it as a travel rule. Basically, it's just the bottom portion of that scale that you saw before, because it counts off angles as a distance along the floor plane. So what I'm going to do is I'm going to come down here and show you exactly how I would lay out 4 and 5 for my rake and my splay to get my resultant and my sight line. So what I do is I come down here and I have 5 here, so it's 5 is going to be my splay. So I put this on my baseline between my two front legs and I put it to the 5. So that's measuring over 5 for me. Then I go up 4, which is going to be my rake, and then I make a little mark. So now I've got a small mark that is 5 traveling this way and 4 traveling this way. When I reconnect that mark back to my center point here, that just gave me my sight line. Now, just like I was able to measure my travel of 5 and my travel of 4, I need to measure the travel from the center point as far out as it went to create the sight line. So what I'm going to do is I'm going to measure that, and when I put it down there, it comes to 6.5 degrees. So when I drill this at 6.5 degrees, leaning along that sight line, I'm going to get the results I want.